Hello and welcome back to Groundhog Graphics. I appreciate the people that have been coming back and watching these videos. Today we're doing a live, and I think we're going to go over screen codes versus PETSCII codes. And before we get started in Power C, I think I'm going to do a little bit of basic. So let's go ahead and let's see how we should do this. Print the alphabet. Let's see. 4. Mind you, I'm a little rusty on my basic. 4A. A equals. Okay, I don't know. Or A equals ASCII. ASC. I think it's a double. ASCII A 2 ASC Z 20 print CHR $sign A. Oh, well, yeah, I guess I would want that. Yeah, and 30 next. See if this runs. It does. Okay, cool. So 5 print Ooh, I'm on an emulator. I'm trying to think, how am I going to do the clear screen on here? Not sure because I don't think all my keys are working. Since I updated my emulator, I've lost some key functionality I need to go through and fix. And when I do fix it, I will update it because I do have the keyboard VKM files for Power C and for Vice. I have those uploaded, but if you're using the very latest version of Vice, then it's not working perfectly, and I need to fix it. So they made some changes in Vice. But let's see. Let me see if I can just clear the screen. That would tell me a lot. Shift, insert, delete, backspace, shift function, page up, home, in. Not looking promising here. Okay, so I'm not going to be able to clear the screen. If I were to go to the top, run. Still not going to do what I want it to do. I mean, we can work with it. List. Okay. Character. Let's not do the whole alphabet. Let's do to C. And then let's do comma A. Semicolon? I don't know if that'll work. Comma is just too much. It's overkill on the spacing. Oh, let's see. I guess it's semicolon, space, semicolon A, semicolon, maybe 2 spaces, and semicolon. Let's try that. There we go. So we see A is 65, B is 66, C is 67. Alrighty. So now, if I go and I print, if I actually peek what's up here, right here in the A, B, C, D, E, F, G, if I go and I peek that, you're going to see that these are different values, or they should be different values. Let's see here. Print, peek, 1024 plus 40. 1. And just to make sure that we have that right, let's go ahead and poke 1024, 2. Oh, the 1024 plus 40, 2. There we go. So we did have it right. So as you can see, when we peek this location where the A is, we're getting a 1. But the PETSCII or ASCII value of A is actually 65. So what I needed, as I was working on before, when I ended up getting sidetracked on this binary save, I was working on a conversion to convert the screen codes to PETSCII and vice versa. So that's where we're at right now. So you can see now definitely there's a difference between what is in screen memory versus what we will print to the screen. For the PETSCII is different than the screen codes. And there's listings online for screen codes and PETSCII if you want to go look that up. So now I think we're ready to progress to Power C. Oh, you know what? I don't know. I thought I had my... Oh, maybe I do. Let me see. My video. Yeah, okay. I got my camera on. Alright, so anyway, let's go ahead and mount disk drives. Truck D81, 9, truck D64. 0. And so I have B save on here. I don't need B save on here. I got a lot of files on this disk. I'm getting concerned that I'm going to run out of file space or something else, but I could have swore I made a program once to count how many files there were, but I can't remember what it was. But I don't know. I think it's 177 files max, and I don't think that's anywhere near that. All right. So testcode.o. We could remove, let's see, L test ch test.bin. All of these can be removed because I've already made a video yesterday for binary save, and that's what this test code was. So remove that test. what else we might go. If there's anything else I can get rid of on here. Really, I don't need the GGB save on here because I already have it. Work 80. Well, I don't have to do. Well, no, I don't have to do it. Dir. Oh, actually, I can do L. LS will actually list your system disk. So, see, we have work 90. That's for my working disk for in 9. But then I believe, and I hardly ever use this now, sys 80. Yeah, so sys is a system disk. So you can change that too with sys the same as you do work. And I've never shown that before, so I just don't use it that much. Because usually a system is, in 8, and it just defaults there. So if I do ls, it will list everything on the system disk. See, we don't hear any noise because this is a 1581 drive and nobody's put drive noises in for the 1581. See? So there we go. So if I do ls gg asterisk, we have ggb save, c sh, all good. So that means I can just get rid of it off of here. Save us some precious space on our 1541 floppy. All right. So L GGB. And remove GGB asterisk. And let's do an LSCN. Oh, dang it. LSCN. And that's screen codes. So let's remove SCN code .h. See, if you hit a key while you're doing a directory listing, you can pause it. But yeah, I'll show you later. But if you're in the editor, you can also do a directory listing, but you have to do run stop to pause it there. But right here, just any key. It's a new book. Hub.test.c. Truck. Get string. Trip. Then set. Remove commas. Okay. Remove buffman.o. LSRT. Okay. All right. So I'll go to CED, PRCHR set.c. And this little program prints all the PETSCII characters onto the screen. It skips all control characters. Not like the up, down, clear screen, because that would mess this whole thing up. and we don't need them anyway because what we're trying to do is capture screen codes. So you can see it goes to 256, it goes from 0 to 256. And then it looks for anywhere where there are control codes, and it will just change those to spaces. And then it puts the characters to the screen, and then it moves to the next line, and that's all it does. And then what we can use is the new binary save utility to capture all of the screen codes for all the 256 different PETSCII codes, skipping, of course, all the control codes. Alright, so let's go ahead and quit this and PR character set. And then we can do GGB save. And I'm going to change this into a C array. So we're going to go scn code.h, scn code for our array name, and we will do 400 to 500. And I don't plan to edit this, so I don't need it all organized. I'm just going to make it compact. SCN code. Alright, let's take a look at it. CED, SCN code.h. There it is. So those are all the screen codes for all the printable symbols from PETSCII. Right there. So now I can reference them and use them for conversion. So I'm going to make it define up here. Define. Let's see. What would we call it? Pet to SCN. SCN X, and it will be SCN code X. That will reference that direction. What about the other direction? That one will require a search. I'm going to go screen code to PETSCII. That would require a search. Then, that could also be a problem here, I think, too. This may be only good for one direction. If I want to look up and I see a screen code and it's 32, it's going to come back as PETSCII 0. Even though really it should be PETSCII 32. Because PETSCII 32 and screen code 32 are the same. Both are a space. So it would come back incorrectly. So maybe what I should do is instead of making these 32, make them zeros. But 0 then would be an @ symbol. Let's take a look at... Oh, you know what 0 is? 0 is from PETSCII. That's a control code. But if we've got a screen code of 0, that is that. Let's take a look. Opening Firefox here. Let's take a look for Commodore 64 screen codes. And let me switch you guys over so you can see what I'm looking at. Okay, I just had to add my microphone to Vice, not to OBS Studio, so that way you guys can hear me. Okay, so now PETSCII codes, screen codes, right here. All right, so @ symbol, character, graphic. Okay, so this starts at 0. Screen code, decimal hex, and then reverse decimal hex. So if we get the @ symbol on the screen, that is a... Oh, yeah, it is 0 on there. So that would not convert well. But what would be very unlikely to encounter, but these would actually be the same. That's not what we want. See, we aren't going to do any graphical characters with this. Just trying to think this out. I want to do a reverse conversion, but I don't want to set everything that we don't accept as 32 because that's a space that we're going to encounter all the time. If we're doing a conversion from screen codes to PETSCII, it's always going to give us the wrong PETSCII value. We don't want that. I want something that we can go, oh, that won't show up. That way it will search the array and find the proper code and do a proper conversion. So, what are we likely not to encounter? I would say FF is the least likely one we would encounter. So maybe we should fill that with 255. Okay, let's see what that looks like, see if that makes any sense. Alright, so quit this and try this again. I'm going to edit PR.C. And we're going to make them all 255. For character 255. Oh God, was that the screen code for? I think they're the same, right? Oh, so, oh, you guys are still on the other view. I'm sorry. Okay, it's the same. So 255. Let me switch you guys to the other view. Nice. There we go. Sorry about that. Okay. Now, C equals 255. That's a character we're not worried about converting. That way everything else should convert okay. Let's go ahead and save this. F2, put PRC set.c. Quit. And we'll compile. Link. Set.o. Interesting. I got an idea. Alright, pure character set.o. And what's that? And we will save this. .sh. Let's try it. There we go. Now, let's try ggb save scn code dot h scn code 400 500 -c. cd scn code dot h. It switched it on me. It switched it on me. See, that's not good. Okay. Alright, sucker. You little sucker, you switched it on me. Alright, clear this. Get appear set print character set. What can I do? You know what? Let's go back to basic by quit by, let's toy with this for a second, print CHR $sign. Oh, yep, $sign 255. Let's get rid of all this. Print $sign 255. And then get rid of this. Come up here. Run. Print peak 1024 plus 40. 94. What if we, let's see here, poke 1024, comma 255. So there's no way to print it from the PETSCII. Let me see here.